So on number 22, it says Castell and Daniel each improved their yards by planting rose bushes and shrubs. So if you write rose bushes and shrubs as your two things that are going on, they bought their supplies from the same store. Castell spent $192 on 12 rose bushes and 9 shrubs. And they spent $192. And Daniel spent $50 on 2 rose bushes and 3 shrubs. It says find the cost of 1 rose bush and the cost of 1 shrub. So when we think about what we're multiplying by, 12 rose bushes times the cost of a rose bush plus $9 times, 9 shrubs times the cost of the shrub equals $192, which kind of makes sense, right? The number of the items times the cost is the total price. So in both cases, I've got this going on. Okay, now I didn't say how to solve it, I guess. You could actually use substitution, elimination, or you use the calculator using RREF, and that's what I'm okay with you doing. So if we do that, then I'm going to go to the calculator and do second matrix over to math and up to RREF. So second matrix over to math and then up or down to RREF, press enter. And do you guys know how to put in the matrix? Alpha zoom. So alpha zoom. And this is a 2-row by 3-column matrix. So 2 by 3. And then I just enter in the numbers. So 12, 9, 192, 2, 3, and 50. And I get x equals 7 and y equals 12, but I have to actually answer the question. It says find the cost of 1 rose bush. So 1 rose bush is $7, and 1 shrub is $12. And that's all we gotta do on that one. I don't know if that was maybe confusing because I didn't give directions on it, but that's what I was thinking. Okay, on 23, solve each system by elimination on a piece of notebook paper and attach it to the review. Check your solutions using RREF. Okay. So, for this first one, 23, I've got negative 2x plus 3y plus 3z equals a negative 4. X plus y minus z equals a negative 4. And negative 2x plus y plus 3z equals 2. So I don't know if you guys remember, but with elimination, the idea is to cancel out variables, eliminate the variables, if you will. So the first thing I did was number the equations 1, 2, and 3, or A, B, C, however you want to do it. And then we picked a variable to eliminate, and I noticed that for x's, if I were to multiply row 2 by 2 and I add it to row 1, I would get the x's to cancel out, right? If I multiplied row 2 by 2 and I added it to row 3, I would get the x's to cancel out, and I need to do that twice. You have to eliminate the variable twice. So x is a good option. Y, what can I do with y? Right, if I multiply this row by negative 3 and add it to the first row, that cancels out. I could do the same thing with row 3, right? And then for z's, all I got to do with the first and the third is make one of them negative, and then I could just multiply the second row by 3 and cancel out with z. So does it matter? So what do you want to do? I heard someone say z, so I'm going to do z's. Okay, so I'm going to take row 1, and I'm going to add it to a negative 1 times row 3. So first I'm going to use row 1 and 3. and I'm going to make the second one negative. So I'm going to write row 1 out, negative 2x plus 3y plus 3z equals a negative 4. And row 3 I'm going to multiply by a negative, which just makes that positive 2x, a negative y, a negative 3z, and a negative 2. Now in this one something very nice happens. What is that something? The x's also cancel out. So that cancels out, that cancels out. What am I left with right here? 2y. 3y minus 1y is 2y, and 2y equals what? Negative 6. So divide by 2 and I get y equals a negative 3. Okay. At this point, what I need to do is I'm going to go ahead and, since I picked z's, I'm going to go with z's. But at this point, as long as I cancel out x or z in another pair, as long as I can plug in y, I'm good. But I'm going to go ahead and go with z's again. So I'm going to pick row 1 and row 2. As long as I don't pick 1 and 3 again, I'm good. So I'm going to pick row 1 and row 2, but I'm going to multiply row 2 by 3. So row 1 plus 3 times row 2. So row 1 plus 3 times row 2, which makes that a negative 3. So row 1 is negative 2x plus 3y plus 3z equals a negative 4. And 3 times row 2 is 3x plus 3y minus 3z equals a negative 12. So I just multiplied everything in row 2 by 3. 3, 3, negative 12. And then I combine. What is 3x and negative 2x? X. What's 3y plus 3y? 6y. The z's cancel out as they should. What's negative 4 and negative 12? Negative 16. Now, if I had had an equation over here, then I would have stacked the two equations and done elimination on a smaller scale. But as it is, I don't have to, because I already know that y equals what? Negative 3. So if y equals negative 3, then I know that x minus 18, because 6 times a negative 3 is negative 18, equals a negative 16, which means x equals what? Yeah, add the 18 over and I get positive 2. Now that I know two variables, what can I do? Plug them in to solve for the third, right? Does it matter which equation I pick? No. 2 has the least amount of multiplication, so I'm going to go ahead and pick 2. So in row 2, I know that x is 2 plus y is negative 3 minus z equals a negative 4. What is 2 plus a negative 3? Negative 1. So negative 1 minus z equals a negative 4. I don't care how you do it. If you add 1 over, you get negative 3 equals negative z. So z equals 3. If you were to add the 4 and add the z, then you get z equals 3. So it really doesn't matter as long as you're able to get rid of the negative in front of the z. So my final answer should be written as a coordinate point. X and then y and then z. X is 2, y is negative 3, and z is positive 3. It does say that it wants you to check using RREF in the calculator. So right quick, I'm just going to plug that in. So just a little reminder, second matrix, over to math, up to RREF. Alpha zoom, it is not a 2 by 3, it's a 3 by 4. And I enter in the numbers. Negative 2, 3, 3, negative 4. 1, 1, negative 1, negative 4. Negative 2, 1, 3, 2. And I get 2, negative 3, 3. Which is what we got. Okay? Did anyone work it a different way that they'd like me to check out and see if it... Okay. If at any point you want me to look over yours to try and find the mistake, if there is one, then I can do that, okay? Sorry, people in the video, I'm too busy staring at people. Okay. Let's do number 24. So, I've got, not that you can see. R plus 2s minus t equals 0. Negative 2r minus s minus t equals 6. Negative 2r plus 2s minus 2t equals 8. So I'm going to number those 1, 2, and 3, and then discuss variables. 1, 2, 3. Okay, R looks pretty easy. If I multiply the top one by 2, and I add it to the second one, and then I add it to the third one in 2 different ways, I've canceled out R. 2 looks easy. If I multiply this by 2, I can cancel out with that, and I can cancel out with that when I add them. And T is easy as well. It's just annoying with the all negative. So I would maybe multiply the first row by a negative 2 to make it a positive 2 to cancel out with the negative 2, and do the same thing with row 2. But it seems to me that R or S are the easiest. So what do y'all want to do, R or S? R. Okay. So I'm going to multiply row 1 by what? So 2 times row 1, and I'm going to add it to row 2, and then I'm going to do 2 times row 1 and add it to row 3. But we'll do this one first. So 2 times row 1. So 2r plus 4s minus 2t equals 0 times 2, which is 0. And then I just put row 2. Negative 2r minus s minus t equals 6. Alright, so row 1 times 2, add row 2. I'm going to go ahead and add them. Those cancel out, and I'm left with 3s, because that's 4s minus 1s. And minus 3t equals 6. With this equation right here, what could I do? I could divide it by 3 and make it s minus t equals 2. If you want to, it makes it a whole lot easier. And if you can go ahead and do that, I suggest you do. Alright, for the second time I do this, because I've got to eliminate the variable twice. We targeted r. I'm still going to multiply row 1 by 2, but I'm now going to add it to row 3. So 2 times row 1 is still right there. 2r plus 4s minus 2t equals 0. And I'm going to add it to row 3, which is a negative 2r plus 2s minus 2t equals 8. Those cancel out, and I'm left with 6s minus 4t equals 8. Again, what do these divide by? 2. So I'm going to go ahead and write them as 3s minus 2t equals 4. Now, is there anything wrong with you going back and using the original? Like before I simplified. If you then stacked these, 3s minus 3t equals 6 over 6s minus 4t equals 8. Could you eliminate a variable right there? Which variable would be the easiest to eliminate? S? 3 and 4 both go into 12. You'd have to multiply them by each other, and one of them would be a negative. 3 goes into 6, so I would just have to multiply the top row by what? 2? Negative 2. I don't want to multiply that by a negative 2. But I could, and it would work out. And that pin's bit the dust. Okay. But if I go ahead and use the simplified ones, s minus t equals 2 and 3s minus 2t equals 4, I mean, I'm still going to have to multiply. What would you multiply? The top one by what? Negative 2? Okay, or negative 3. I would probably do negative 3, but it really doesn't matter. It's just preference at this point. But I can show you that I can get the same thing. Here I get, I'm going to just write this above it. Negative 6s plus 6t equals a negative 12. If I add them, I'm left with 2t equals a negative 4, so t equals a negative 2. If I put this, I've got negative 3s, negative 3 times negative t is a positive 3t, and negative 3 times 2 is a negative 6. I get these canceled out, I get t equals a negative 2. So it really doesn't matter if you simplify or not. As long as you know what to do, you can work it out. Okay, I know t equals negative 2. What am I going to do with that? Plug it in where? What do you think, guys? into the equations? The original or the two variable? The two variable. If I plug in the original, I'll still have two unknowns. So does it matter which one? It doesn't. I could use the simplify, but I'll go ahead and just use one of the original. I'm going to go and use that one. 3s minus 3t. And I hate s's. I will not put s's on your test, okay? So okay, 5's everywhere. 3s minus 3 times negative 2 equals 6. So 3s plus 6 equals 6. If I subtract 6 over, what do I get? 0. If I divide by 3, I get still 0. Is it okay that s equals 0? Sure. 0 is a number 2. Well, not a number 2, but it's a number TOO. Okay, now what do I do? To where? The first equations? I've got t equals negative 2, and I've got the s equals 0. I need r. Does it matter which equation I use? It does not, so I'll use the first one. R plus, it's the easiest one to solve for r, plus 2s, which is 2 times 0, minus t, so minus a negative 2 equals 0. R plus 0 plus 2 equals 0. R equals a negative 2. So in order, R, S, T, R, S, T. Okay? Does that bring back your memory on those a little bit? Okay. Am I likely to put one of those on the test? Yeah. So it's definitely something worth looking over, making sure you know. Okay, let's go to 25, I guess. So a lot of you probably already have this done, so feel free to just keep working while I go through these. On number 25, I've got the fifth root of negative 192, x to the ninth, y to the sixth. So when you're doing these roots, it's, you will have the power chart in front of you. But if I need to, then I can start just simplifying and going from there. So I look at 192, and I look at powers of 5. And powers of 5, 32, 243. Okay, 243 is already too big, so my only hope is 32, to see if 32 goes into it. I could try it. I could start multiplying things around. If you think about 32, and again, I mean, we don't have a calculator, so I know that 32 times 2 would be 64. So that's 1, 2. Add another 32, and that would be 96. So that's times 3. Add another 32, and I get, let's see, 8. So 128. Add another 32, and I would get, that's 10, so 60, 160. And then 6, add another 32, and I get 192. So that means 32 goes into it 6 times. But here's another option. Just start breaking down 192. I didn't use that space, I'll use it up here. So 192 is 2 times what? If I don't know, I'm going to use long division right quick. 192. 2 goes into 19 9 times. That leaves me with 18. Subtract 1, or subtract and I get 1. Bring down the 2. I got 12. I don't know if you can read that, but 2 goes into 12 6 times. So 2 times 96, which is 2 times 96 is 2 times 96, so 48, which is 2 times 2 times 48 is 2 times 24, which is 2 times 12. You might be like, oh, why is she doing this? But it'll make sense in a minute. And 12 is, so I've got 2 times 2 times 2 times 2 times 12, which is 2 times 6, which is 2 times 3. So if I think about it, that's 1, 2, 3, 4, 5, 6 2's. Yeah? Okay. So over here, I'm just going to kind of do an exploration, fifth root of 192. I can either think of 192 as 32 times 6 because I worked it out and I figured out that the only fifth root, the fifth power that goes into it is 32. And the fifth root of 32 is what? The fifth root of 32 is 2, so 2 comes on the outside and 6 stays on the inside, right? The other option is I think of it as the fifth root of 2 to the 6th times 3. And I ask myself, how many times does 5 go into 6? One time, so I bring 1, 2 on the outside, and I leave how many on the inside? Right. 5 goes into 6 one time with 1 left over, but times the 3 left over, and I've got a 6 on the inside. Does that make sense? I can either work it out using my power chart and figuring out if 32 goes into it, or I can just break it down into prime factors and see what I've got and just powers. But anyway, I've got the fifth root of negative 32 times 6, x to the 9th, y to the 6th. Okay, what's the fifth root of a negative? What's the fifth root of a negative? Is it negative or positive? If I think about an odd number of negatives, that's negative. That's positive, right? That's negative. 3 negatives makes a negative. Negative times a negative is positive times a negative is negative. An even number is positive. So when I have 5, the fifth root of negative 32 is a negative 2. And I leave the 6 on the inside. And then I just ask myself, how many times does 5 go into 9? Once with, how many left over? 4. 5 goes into 6, one time with 1 left over. Do you have to put the powers of 1? No. Okay. Let's go to number 26. This is actually pretty small compared to the other one. It's the square root of 100 x squared y cubed. Is there a square root of 100? It's what? 10. That's an understood 2. How many times does 2 go into 2? One time. How many times does 2 go into 3? One time with 1 left over. You don't have to put the 2 there, but I did. So there you go. So it's just 10xy times the square root of y. Okay, on number 27, I've got the square root of 144x y squared z cubed. That's kind of boring. I guess I'll leave it. What's the square root of 144? 12. So I've got 12. How many times does the understood 2 go into 1? It doesn't, right? So I leave the x on the inside. How many times does 2 go into 2? One time, with none left over. And then how many times does 2 go into 3? One time with 1 left over. And there's my answer. 12yz times the square root of xz. On the last test, I had to count off a lot of little quarter points for not putting the root right there. If it was a cubed root, we forgot to put the 3 there. But that's basically it. Oh, well, that's smudged. 12yz times the square root of xz. Okay, let's go to 28. 28 is the fourth root of 243. So I look across the powers of 4, and I don't see it, but I see 243 on 3 to the 5th, right? So I'm going to think of that as 3 to the 5th and treat it just like I would treat x to the 8th. I ask myself, how many times does the root go into the power, and then I go from there. So how many times does 4 go into 5? One time. So I put a 3 on the outside, with how many left over? 1. So I have a 3 to the first on the inside. Yeah? On. Are you done with your review? Okay, all right. Should make sure you aren't on your phone, because then I would have to call the police. Okay. Okay. So, how many times does 4 go into 8? With none left over. How many times does 4 go into 14? 3 times. That's 12 with 2 remaining. And how many times does 4 go into 7? 1 time with 3 remaining. Oh, well, good thing I showed that. So 3x squared y cubed z times the 4th root of 3y squared z cubed. Can you read that that is a 3? Probably not. There we go. Okay. On number 29, we gotta multiply, yeah? Okay, so the only thing on the outside is a 6, so I'll keep that there. And it's the square root. I've got 2 times 20, which is what? 40. I've got x to the 4th times x cubed, that's what? X to the 7th, and y to the 6th times y to the 8th? Y to the 14th. So then I just need to simplify. It's a square root, which is why I went ahead and multiplied 2 and 20 instead of breaking it down. What perfect square goes into 40? 4 goes into it 10 times, yeah? So what do I bring on the outside? A 2. Do I add it to the 6 or multiply? Multiply, because it's 6 times that, right? So 6 times 2, which is 12. And then what stays on the inside? The 10. Okay, and then I ask myself, how many times does 2 go into 7? 3 times with 1 remaining. 2 goes into 14. 7 times with none remaining, right? So there's my answer. Okay. Number 30 is a little bit uglier. So let's do it. What's the only number on the outside? -5. So I'm going to go ahead and write that. -5 times the cubed root of... Now, I'm not actually going to multiply 24 and 10. I'm just going to write 24 times the -10, or -24 times 10. I'm just going to put the negative in the front. Make it easy. A to the what? 11. B to the 15. And C to the 7. Okay. So, 24 and 10. If you multiply that, you get 240. Is 240 on your power chart under powers of 3? No. You have options. You could try and divide. I prefer to go ahead and just break it down into prime factors. So that's what I'm going to do. So I'm going to use the space right here, and I'm going to think about that. 24 times 10. What's 24? What is it? 8 times 3? And then, now, okay, this right here, though, technically you could just say, well, I know it's divisible by 8, and 8's a perfect cube, right? And go ahead and take the cube root of that out. But if you don't think to do that, maybe you did 4 times 6, then I'll just keep going. What's 10? 2 times 5. What's 8? 4 times 2, and 4 is 2 times 2. So this is 3 2's times 3 times 2 times 5. So if I broke it down, that would be 2 to the what? 4th times 3 times 5. Yeah? So when I think about the cubed root of that, the cubed root of 2 to the 4th times, am I going to be able to take the cubed root of 3 or 5? No, they have a power of 1, so I'm just going to say 2 to the 4th times 15. What can I do? Right. 3 goes into 4 one time, so I bring a 2 on the outside, and I'm left with only 1 on the inside, and so I'm left with a 2 on the outside and a 30 on the inside, right? Okay. What about this negative? I've got the cubed root of a negative. What does that do? It's negative. So that negative comes out and makes this what? Positive. So not only did I bring a negative out and make that positive, I also brought a 2 out, which makes it what? 10. So I've got 10, and then the cubed root. So remember, I took a 2 out. I had 1 2 left over, so 2 times 15 is 30. And then the negative comes out and makes that positive. Only because it's an odd root. And then I just do variables. So how many times does 3 go into 11? 3 times with 2 left over. And then how many times does 3 go into 15? 5 times evenly. So b to the 5th. And then how many times does 3 go into 7? Twice. So c squared with 1 left over. And there's my answer. With the 240, if you wanted to, with powers of 3, I mean, obviously 216 doesn't go into it. 125 does not go into it. You could test 64, 27, and 8 by just doing division, but I know 8 goes into it because it's 24 times 3, or sorry, it's 24, right? So it's 8 times 3. So I could have just said right here, 8 times 30. And then I know that the square root of 8 is 2, the cubed root of 8 is 2, and then 30, it doesn't have a perfect cube, so I'm done. All right, let's do 31. So 31, I need to multiply it out, yeah? Distribute. So in 31, I multiply 3 times negative 1, and I get negative 3. And then I multiply 3 times the square root of 2, and I get what? 3 square roots of 2. I multiply 5 square roots of 2 times negative 1, and I get negative 5 square roots of 2. And then the one that trips everybody up is 5 square roots of 2 times square root of 2. What is 5 square roots of 2 times the square root of 2? Why? Right, 5 square root of 2 times the square root of 2 is 10, because square root of 2 times square root of 2 is either square root of 4, which is 2, or the square root of 2 squared, which is 2, because they cancel each other out. Either way, I get 5 times 2, which is 10. And then I just combine like terms. So what is negative 3 plus 10? Positive 7. And then 3 square roots of 2 minus 5 square roots of 2? Negative 2 square roots of 2. Okay. On number 32. I'm going to multiply by the what? The conjugate of the denominator. It's going to be a little bit ugly and weird because they're different roots, but you can still multiply. 5 minus 5 root 3 on top and bottom. And it's not, we don't change the sign of the number in front because it's just a plus bi versus a minus bi. The only thing that changes is the sign in the middle. Okay? So, I'll start multiplying it out. What is 2 times 5? 10. What is 2 times a negative 5 root 3? Negative 10 root 3. What is negative square root of 5 times 5? Negative 5 root 5. And negative square root of 5 times 5 square roots of 3. So negative square root of 5 times negative 5 square roots of 3. What's a negative times a negative 5? Positive 5. What's the square root of 5 times the square root of 3? Square root of 15. So it's just plus 5 root 15. Can I combine anything in that numerator? No. So my numerator is just that. Now let's talk denominator. Okay, in conjugate pairs, the middle term should cancel out, but I'm going to go ahead and check it right quick. I'm going to go ahead and leave this. I'm going to do my multiplication over here so that I can just write the simplified version right there, and that'll be my answer. So when I multiply it out, what's 5 times 5? 25. 5 times negative 5 root 3 is negative 25 root 3. And 5 root 3 times 5 is positive 25 root 3, which cancels out. So then I just multiply 5 root 3 times negative 5 root 3. So I've got 5 root 3 times negative 5 root 3. What is a negative 5 times a 5? Negative 25. What's square root of 3 times square root of 3? And what's that? Negative 75. What's 25 minus 75? Negative 50. So I put a negative 50 there. Is that an acceptable final answer? What's the only thing I don't like about it? Yeah, there's a couple things that I can actually do. It simplifies because the 10 in front, the 5 in the front, the 5 in the front, and the 50 are all divisible by 5. So that is something. I divide them all by 5 and I get what? Wait, do I want to do anything else at the same time? Get rid of the negative, yeah. So if I divide by a negative, basically all it does is change the sign. So that becomes negative, that becomes positive. That becomes positive, and that becomes negative, and then that becomes positive. Yeah? And then I'm going to divide everything by 5. So I've got negative 2 plus 2 root 3 minus 1 root 5, or just root 5, minus, plus, just kidding. Plus, what happened to my, oh yeah. 10 divided by 5 is 2, 10 divided by 5 is 2, 5 divided by 5 is 1, 5 divided by 5 is 1, so square root of 15. All over what? 10, because I divided by 5. And there you go. Okay. Let's go to number 33. Write each expression in radical form. What do I want you to do? Guys, what are you supposed to write? What does it mean when it says radical? The root, yeah? Okay. What's the root? Oh, good. I was like, I don't know what happened to it. What's the root? Square, it's the 2. Do I have to write it? You actually don't. I'm going to go ahead and write it, but you don't have to. What goes on the inside? 5b is being raised to what power? The first power? Okay, just as a word of caution, what if it had been 5b to the 4, no, not 4, that makes sense, 3 halves. You got to be careful because I think that some people would write this. And is that right? What's the only thing being cubed in that expression? The b. And so if you wrote it like that, that would be fine. Or if you wrote it like this, 5 cubed is 125, and then said that. That would be okay. Is it more likely that I'm going to give you something with a different power than 1? Yeah, probably. Okay, so on 34. But that's not the answer. The answer is this one. Perfect. This is rude. I know, I should. Good. It's a painting, and it's beautiful. All right, number 34. Which one's the root? I don't know if some of you on your test were like just hedging your bets and you did one way and another the other way, but like make sure that you're consistent maybe. Maybe I can be consistent with error, but I had within 3 problems 2 different methods and going back and forth. It was quite beautiful. Backgammon, I used the pen that bleeds again. Perfect. Done. That looks funny. Perfect. Yep. Once you can see it. Or can you write it like this? Yes. Yeah, that's fine. It actually doesn't look too bad on my paper, but the way you see it, yeah. All right, all right. I mean, it looks like I'm coloring with a marker, but it's a highlighter, so. I know. Yeah. This is really upsetting. Okay. Look, I have another color. Let's see how much pink smudges. We're out of time. Oh, perfect. See, it's a highlighter, but that looks like it's a marker. Goodbye.